let's talk about one of the biggest fears anyone has when they fly. Picture this. You're 6 miles up in the air, you hear a loud bang, and you look out your window to see smoke pouring from an engine. For most people, that's the absolute nightmare scenario. But is it really game over? The first thought that pops into your head is that without an engine, the plane is just going to drop right out of the sky. But that couldn't be further from the truth. In fact, commercial jets are specifically designed to handle this exact situation. It's a problem that engineers actually solved a long time ago. So this isn't about luck. It's about some truly brilliant engineering and a core principle called redundancy. Your safety at 30,000 feet is literally built on the idea that things can, and sometimes will, fail. So let's break down how it works. The best way to think of a jet engine is like its own little power plant hanging on the wing. Its entire job is to suck in huge amounts of air and use it to generate 2 forces that are absolutely critical to making flight possible. The first and most obvious one is thrust. This is just raw, brute force that shoves a multi-100-ton airplane forward, fighting against all that air resistance. Simple, right? No thrust, no go. And that forward motion is essential for the second force, lift. As the engines push the plane forward, air starts rushing over those specially shaped wings. This creates a difference in pressure, less on top, more on the bottom, that literally lifts the plane up into the sky. So you can see how thrust and lift are totally connected. And here's the real secret to modern aviation safety. A twin-engine jet isn't designed with 2 engines that each do half the work. Nope. Instead, each engine is so powerful that it can handle almost all the work by itself. It's a planned, built-in backup. So how much backup are we talking about? Get this. A Boeing 777 is certified to fly for 5.5 hours on just 1 engine. That's more than enough time to fly from New York all the way to Los Angeles. A single engine failure usually doesn't even mean an emergency landing nearby. It just means the plane keeps on flying. So the really crucial thing to remember is this. While it might be a pretty startling experience for you as a passenger, for the pilots and for the aircraft itself, a single engine failure is a known, manageable event. It's a scenario they have trained for over and over and over again. Okay, that's 1 engine, but what if the absolute unthinkable happens? What if you lose all engine power? Surely that has to be it, right? Well, not quite. This is where the plane's most basic design feature kicks in. When a plane loses all its engine power, it doesn't turn into a brick. It turns into a very sophisticated glider. As long as the wings are still attached, they will generate lift if there's air moving over them. And the plane's forward momentum doesn't just vanish. A skilled pilot can use that momentum to put the plane into a stable, controlled glide, slowly descending while covering a surprising amount of ground. And pilots aren't just guessing here. This is a rehearsed procedure. Priority 1 is to stabilize the plane into that perfect glide to maximize their time in the air. Next, they get on the radio to air traffic control to find the closest runway. From there, it's all about skill, guiding this giant glider down for a safe landing. And they aren't doing this blind. Pilots have specific tools to help them out. There's a glide slope indicator that helps them maintain the perfect angle down to a runway. They can use the flaps and spoilers on the wings to control their speed precisely. And of course, nothing replaces the most important tool of all, the pilot's own training and experience. This incredible level of safety we have today didn't just appear out of thin air. Modern aviation is built on lessons learned from the past, sometimes from really tragic failures that led to revolutionary changes in how we design and fly. And the results really speak for themselves. Statistically, flying is by far the safest way to travel. The probability of an accident is something like 1 in a million, way lower than traveling by car or even by train. And that safety record is a direct result of learning from mistakes. A perfect example of this is the story of the de Havilland Comet. Back in the early 1950s, it was the coolest thing in the sky, the future of travel. But within just 1 year, 3 of these amazing jets tragically fell apart in midair. Investigators were completely stumped until they uncovered a tiny but absolutely fatal design flaw. The flaw was something every passenger looked at: the windows. They were square. See, at high altitudes, the pressure difference between inside and outside puts huge stress on the plane's metal skin. With a square window, all that stress gets concentrated right at the 4 sharp corners, eventually causing the metal to crack. By simply rounding the corners, engineers could spread that stress out evenly, getting rid of the weak spots. So every single time you look out a round airplane window, you're looking at a life-saving lesson learned from history.
And just like we learned from design flaws, we study exactly why engines might fail. The most common reasons are actually well known and constantly being worked on. Things like issues with the fuel, simple mechanical wear and tear, ice building up, or even bird strikes. These are all understood risks that have procedures and maintenance checks designed to prevent them.
So the next time you're flying, just remember this. The incredible safety of your trip isn't a matter of luck or chance. It's the result of decades of brilliant design, careful planning, and learning from every single mistake along the way. It is, quite simply, safety by design.